are you? I'm Gary, and thanks for taking the time to watch this presentation on addressing common DSA problems in Swift, and specifically making them more Swifty. These DSA problems are often presented as part of job interviews, so they provide a useful and semi-practical examples for investigating some of the more advanced features of Swift. Even if you are familiar with the algorithms, you might learn something about the Swift language and the power of its standard library. In this episode, we're going to be looking at the problem of merging overlapping intervals. As usual, I'm not going to explain the algorithm in great detail, but instead look at the issues I have with a proposed solution. These generally seem to be a simple translation from basic pseudocode to something that just runs in Swift. I also take issue with the way some of these problems are defined. In this case, we're going to take a look into what is meant by an interval, and especially the meaning of the word overlapping. To illustrate the coding, I'm going to be using a Swift playground in Xcode, and I've already pasted in a given solution along with some test examples. Let's take a look. So as you can see, we've got the code pasted into an Xcode playground, and just for reference, I've also put in a comment the actual problem as it's specified at the top here. So it says that given an array of time intervals, I'm not quite sure why that's specifically time, where we have an array with two elements, start and end, the task is to merge all the overlapping intervals into one and output the result, which should only have mutually exclusive intervals. Okay, I think I get the idea of that, but I do actually have some problems with the wording. We've got some examples down the bottom here which are looking at using this merge function as it is, and we can see it is working with the results that we expect. So we've got the results down here in the console, and if we just have a look at what's going on here, we can see that the interval 1 to 3, well, that's being merged with the interval 2 to 6, and that's why in the output we have this interval 1 to 6, but 8 doesn't intersect with that, and 15 to 18 doesn't intersect with 8 to 10, so they don't get merged. If we look lower down, we can see now that clearly there's no requirement to have the intervals even sorted in any sort of order. So we've got intervals going 7 to 8, 1 to 5, 2 to 4, 4 to 6. So just looking through them, 1 is clearly the lowest of the start intervals. 1 to 5 overlaps with 2 to 4, so that's just now 1 to 5. And 4 to 6 overlaps with 1 to 5, doesn't it? So that would then go 1 to 6. That doesn't overlap with 7 to 8, so we would expect 1, 6, 7 to 8, and that's the result we've got. Okay, so it's working well. However, I do have an issue with passing in this argument, which is essentially an array of integers wrapped in another array, and that's also what we're outputting. And of course, the problem we've got here is that there's a fundamental assumption that this array of ints has only two elements in it, which is what's then being used when it does the comparison. And I can see in here a whole bunch of sort of indexes of 0 and 1. And what that means is there's a requirement when we call the function that it is well formed. I mean, if for example I delete this element, let's delete 1. Well, that is going to give us now, yeah, we've got an index out of range. Let's have a look at the results. Yeah, I mean, it's crashed. So, well, that's not terribly marvelous. Let's undo that and get it working again. Let's hide these results. What happens if, say, I extend this and put 3 elements in? Oh, now we've got something really strange down at the bottom. Oh, it's even suggesting I can do that. That's very peculiar. Wonder what happens if I do that. Yeah, I'm not really sure what's going on there. So it's not going to crash if you've got more than one element, but or more than two elements, but it's certainly, yeah, the behavior is undefined. Let's put this back to where it was, and we should now be getting the results we expected. So it strikes me that the obvious thing that we want to do here is replace the array of integers with something like a struct, and let's put in struct interval. I've already created this, and I've given it two variables, a lower bound and an upper bound, which will both be integers. And now the idea would be that we can replace that with an interval. We can replace this one also with an interval. And, well, the code's now not going to compile, and we've obviously got issues down here because we need to turn these arrays into an interval. So I'm just going to undo that for the time being, because I want to come back and actually play with this function later. Now, of course, those of you who are experienced Swift engineers will know that this concept of an interval with a lower bound and an upper bound is already expressed in the Swift standard library as either a range or a closed range. And I want to look about what we mean by that, because actually we don't really need to be defining this struct of an interval at all. I think we can just use a range. But I have a problem. Should we be using the standard range, which is technically what they call a half-open range, or a closed range? And moreover, what exactly does this word overlapping mean? Let's switch over to this freeform document to explore the idea of overlapping. Here I've got two rectangles, and they're clearly at the moment they're not overlapping. If I moved one here, we would say that the rectangles are now overlapping, and we can see the area of overlap. We could compute that. Not overlapping, overlapping. Okay, that seems fine. But what happens if I, say, butt them up against each other? Are they overlapping now? I suspect that most of you would say they're not. And, well, if we were to compute the area of overlap, it would be 0. So I think, technically speaking, they're not overlapping. However, let's move on and consider what's happening with these number ranges. Now, these are the ranges that we saw in the example. We've got 1 to 3, 2 to 6, and 8 to 10. Well, clearly 8 to 10, there's no overlapping going on with these, but these two intervals are clearly overlapping, and we can see that what we want to do is merge those so that they're in the range 1 to 6. That seems pretty obvious. What's kind of less obvious is what happens if we have this. Is the range 1 to 3 overlapping with the range 3 to 6? Now, technically speaking, we might say that they're not. But in mathematics, when we would consider, say, these ranges as a representative of a set of numbers, then we would say they overlap if they have a common element. Well, this then begs the question whether or not we are working here with an open range or a closed range. So in Swift, when I say range or open range, and technically it's a half open range, I kind of mean the same thing. And so if what we had here is an open range, and this too may be an open range, then This means all the values up to 1 but not including 3. But here we start and include 3, but we wouldn't technically be including 6. It would be everything up to 6. But that doesn't seem to be how the algorithm is working. So I've got a feeling what we actually ought to be using here is closed ranges. And in mathematics, we use a curved parentheses, such as we have here, when it's an open range or interval, and a square bracket when it's closed. So this is actually, as well as looking like a Swift notation for an array, it's actually also the mathematical notation for what we would use for a fully closed interval. I've said enough here on open and closed ranges, but what we have exposed is that the problem is ill-defined. In this case, it is not entirely clear what is meant by an interval, and the term overlapping is definitely ambiguous. However, I think we need to take a step back, and rather than getting too bogged down with what we mean by interval and overlapping, is, well, what's this problem really trying to solve? What we're trying to achieve is to merge multiple ranges in such a way that we are storing them more efficiently by minimizing the number of ranges. So when the ranges are overlapping, as they are here at the number 3, then we can indeed express it as a single range between 1 and 6. Let's switch back to Xcode and see how the algorithm behaves in this instance. Let's take a look at these examples down at the bottom again. And what concerns me is that these examples were given as part of the definition of the problem, but neither of them actually explore that edge case that we were just discussing, where the intervals are not just overlapping, but, if you like, butting up to one another. Let's run the playground, check that we're getting the results we were expecting. Yes, we are. And now I'm going to change the 2 to a 3, and are we still getting the same result? Yes, we are. Okay. I expect somewhere in the algorithm, and it's here, if instead of saying smaller than or equal to, if we just said smaller than, I've got a feeling that what will happen is, yes, now we've got down the bottom here, 3 is no longer considered to be overlapping. But actually, that's not really what we want the algorithm to be doing. So I'm going to undo that. Let's put the equals back in. And now we've got the algorithm working as it should be. Let's now change the array of integers to closed ranges. So I'm going to insert into here now closed range, and just for the time being I'm going to make it of type int. That is also now going to return a closed range of type int, and what we need to do here is everywhere where the inner array was being referenced with indexes 0 and 1, we're going to change that to being the lower bound and the upper bound of the range respectively. It's the lower bound. This results array called merged, well, it's no longer that, but actually we don't need to specify what it is. Swift can infer what the type of array is from how we define it here. Okay, so we need to change all of these to, that's to lower bound. That's referencing, in that case, the upper bound. And we need to change the last upper bound to the max here of the last upper bound and the current upper bound. Okay. Oh, we've got a problem. So cannot assign property upper bound is a let constant. Ah, is it? Let's just have a quick look at the definition of a closed range. Oh yes, the lower bound and the upper bound are defined as let. So we can never change them. We're going to have to recreate that particular range. So even though we've got last removed from the array but declared as a var, we still can't change the upper bound. That's not really a problem. Instead, we'll just declare a new last range, and that would be the last lower bound up to and including this new upper bound. Okay, that compiles. But of course, all the examples at the bottom, well, they need to be rewritten so that we change these arrays into closed ranges. Well, as you might expect, I created a code snippet. So that's changed all of them for us. And now we're getting the output that we were getting before, but instead of being an array of integers, we've got closed ranges instead. But the size of the ranges are all the same. Okay, let's move up to the top and think about how we can make this generic. The first thing I'm going to do is I'm going to wrap this function in an extension, and the extension is going to be on array. So let's do that. Now we don't actually need to pass any parameters in at all. We can just call merge on the array. But we need to constrain the array in some way. We need to say it's an array where the element is equal to, it's going to be a closed range with its generic bound. Oh, it can't find bound in scope. Oh, no, that's because, no, the bound is on the element, so we need to do that. Okay. Oh, same type constraint, element equals closed range element is recursive. Oh, we can't define the element as a closed range where we're referencing the element. That definition's recursive. Now, there is a workaround for this, but it's a little bit of a kludge, and it's one that I'm really not happy using. So what we're going to do is we're not going to put the constraint on the array as such. We're going to put the constraint on the function merge. So to do that, I'm going to need to declare a type on here before we start, which is the generic bound. And what we're going to be returning now is a closed range with bound. Okay. But we also need to put in another condition here where we're going to say where the element, because we are working on an array, equals a closed range with a bound. And it knows what bound is now because we declared it at the front of the function. Okay. Let's go through and fix the other errors. Well, we don't have intervals anymore, but actually the count is now working on the array, so we can just delete that. And we're not going to be returning intervals, we're going to be returning self, where we're either empty or a single interval. Sorted can be called directly on the array. And the other last problem we've got here is the use of max refers to an instance method rather than a global function in module Swift. So it thinks the max function is on array, but it isn't. We need to refer to the module that it comes from. And basically it's declared in Swift, and Xcode is offering to fix this for us just by inserting Swift dot in front of it. And if we do that, we should find, yes, it's now compiling. Well, of course, down here we've fundamentally changed how we call it. So what I need to do is not call merge with ranges 1 as the argument, but instead put merge in here. And we need to do the same on ranges 2. Okay, do we get the same output? Yes, we do. Okay, but we're now working with generics. So what would be an interesting thing to do is if I just change that 7 and make it 0.7.0, does it infer now that, yes it does, that all of these ranges, Swift has inferred are in fact doubles. And when we look at the output down here in the console, we can see that the output has changed from integers to doubles. If I change it back, we're back to integers. Let's leave it as doubles. Now, as I had said, we should now, we're working with generics, be able to do this with ranges of anything that conforms to comparable. So how about if we try and use dates? Now I've rather kludged the way that we create the dates, but it illustrates the point. Unfortunately, date is not in scope. No, we need to import foundation because it's not part of the Swift standard library. So now that we've imported foundation, we can see that, yeah, indeed, it has created these closed ranges of dates. We've got this going from, yeah, the beginning of 1970 up till the 11th of March. And then we've got another closed range in 1970 from the 23rd of March up to now. And you can see the time at which I'm recording this. It's not really good practice to put import modules in the middle of the code, so I'll just move that up to the top. And yep, we're still working. So that's it for making most of the code changes for today. We've changed the array of integers for expressing an interval into a Swift closed range type, and we've also made that generic, so the algorithm can work now with, if you like, intervals or ranges of any comparable type. And I think that also is another video that illustrates the real power of Swift, particularly when we're using generics. However, there is one more small change, and it's a very small change, that I want to make to the code. And it's in the name of the function merge. Let's just have a look at what it is that the Swift documentation tells us about naming functions. It says that we should name functions and methods according to their side effects. If we have a look, it says those without side effects should read as noun phrases. Those with side effects should read as imperative verb phrases. Name mutating and non-mutating method pairs consistently. Well, we don't actually have a mutating function here. The merge function doesn't change or mutate the underlying array. Instead, it returns a new array. A mutating method will often have a non-mutating variant with similar semantics, but that returns a new value rather than updating an instance in place. Well, that's what we have here. When the operation is naturally described by a verb, which it is here, the verb is to merge, use the verb's imperative for the mutating method and apply the ed or ing suffix to name its non-mutating counterpart. So in other words, we should call this function merge, which is the imperative of the verb, when we're mutating. But because we're not mutating, this function should technically be called merged. That's a really small and subtle change, and clearly it doesn't affect the way the code works or it's compiled, but it is following the Swift guidelines much more precisely. And if we're going to become good, consistent Swift engineers, it's these little details that count. Clearly, down here now, I need to change all the places where the function's being called to merged. And we're working again. So that's just about it for this DSA solution. But there is just one more thing. It turns out that in iOS 18, Apple introduced something called a range set. And, well, what exactly is that? Let's have a look. Well, a range set is kind of what you expect. It's a collection of ranges. So I wonder if that is doing or can do the sort of thing that we're doing here. So I appreciate that when we use these sorts of features and functionality that's in the standard library, we're not actually then solving a DSA problem, which is what we may need to find that we're doing in an interview situation. But I still think it's interesting to know that they exist and also how they work. So this is a set of ranges, and it's quite interesting in here. If we read it, it says that it creates a range set containing the values in the given ranges. Any empty ranges in ranges are ignored, and non-empty ranges are merged to eliminate any, and here's this word again, overlaps. As such, the ranges collection in the resulting range set may not be equivalent to the sequence of ranges passed to this initializer, and we can pass in some sequence of ranges. Okay, well, that sounds like fun. Let's I just wonder, is there also, since we felt that we should be working with, is there a closed range set? Let's have a look at that. Oh, cannot find closed range set in scope. No, it turns out there isn't. There is in fact only a range set. And given all the different types of potential ranges that you can have, for example, we've looked at range and closed range, but there are also partial ranges going from, through, up to. I'm not going to discuss them here, but there's only just the range set. Well, that means it's going to be presumably working with half-open ranges. I wonder how it actually works. Let's create one and just have a quick play. What I'm going to do is I'm going to create a range set, and I'm going to use this one here at the top. And I should just be able to paste that array in and then say I want to print the range set. Except it can't use that one because these are closed ranges, and remember it's working with these half open ranges. So if we do this, that should work. Oh, and indeed it does. Oh, and look, it's creating the similar output to what we've got, except instead of being a closed range, it's a range. And well, these two are obviously overlapping because I've got the 2 in here. So if I change that to a 3 because it's half open, I'm guessing then we'll get a different result. Oh, we don't. Oh, this is strange because we are actually working with integers, and let's just go back here and see what's happening. You see, when they're integers, and that's half open, it doesn't include 3. In fact, it doesn't include any of the numbers between 2 and 3. That's what that range looks like. And similarly, that is in fact all the numbers up to and including 5, because we've just got integers. There's a big gap here between the 2 and the 3. There is no way that these are technically overlapping in any kind of interpretation. And this is why I've got a problem with the word overlapping. So is Swift's range set just not working properly? Well, no, I think it is working okay, and I'm pretty confident in all of the people that have looked at this and evaluated its functionality. But let's just think again about what it's doing. Here we've got a range of 1 to 2 inclusive, but no 3. 3 doesn't come in until this second range. But actually, if we were going to merge them, it doesn't really matter if there's a gap here, because if we're working with integers, well, there is no 2.5. And if we were working with doubles, for example, it would be all the numbers up to and but not including 3. But that's okay because we've still got 3 here. By merging them, we're not actually filling in gaps or putting in numbers that aren't there. So actually the range set is still working correctly and how we would expect it to. In fact, maybe we could have quite happily used ranges in our solution. A question that I'm going to leave with you to think about. Although range set doesn't technically conform to the set algebra protocol, it does still nonetheless support a bunch of set operations. Let's have a look. So there are set operations that can be performed, such as union, subtract, intersection, symmetric difference. So the question is, why is it working with a half-open range rather than a closed range? And does working with closed ranges on set operations present any problems? I'm going to leave you with that to think about. So that's it for this episode. I hope you found it interesting and maybe you learnt something about Swift. But now I want to hear from you. Do you have any thoughts on the choice of a half-open range for the range set? What about the use of the word overlapping? Let me know in the comments below. And if you'd like to see more videos like this, remember to click the like button, subscribe to the channel and get notifications about new episodes. So until the next time, I'll say thank you so much for watching and I hope you have a great day.